Hello everyone, welcome to my channel, and today we are going to solve today's Leetcode problem. And I haven't seen this problem before. You see an attempted thing here because of like a touch, because of a misclick which I like while taking screenshots. I accidentally clicked over here, like clicked over submit in my tablet. So you see this is basically a simple compile error thing. This is an empty code, right? So yeah, this is I haven't seen this problem before. The basic agenda of the session is to solve this problem right away, where we read the problem and build our algorithm, and then finally convert it into a code which is actually the solution to this problem. We will do all of this without in on the spot, without any kind of help or without any kind of reference to the solution. Okay, without any further ado, I'll just check if we are live or not. Then I'll just start the step one, which is reading the problem. Or without any kind of reference to the solution. Cool, the audio check is done. Now let's come to the solution. And now I'll take you to my tablet where we solve this up. Right, so this is the problem of the day, and the problem says most profitable path in a tree. So we are given a tree, correct? There is an undirected tree with n nodes labeled from 0 to n minus 1. So there is a tree which is undirected, and there are some nodes labeled from 0 to n minus 1. So there are n nodes, basically each node has unique value, and the value lies between 0 to 1, 0 to n minus 1. There are total n nodes here. Rooted at node equals to 0. So this is the root node. You are given a 2D integer array edges. So we are given 2D integer array edges. Okay, which denotes if edges I equals to this has length n minus 1, means what it has, where edges I is itself an array, and it indicates that there is an edge between node AI and BI in the tree, and each element is like AI, BI, there is an edge, right? At every node I, there is a gate. So what does it say? At every node I, there is a gate. You are also given the array of integers. At each node there is a gate. What they mean by gate is, so right now the problem is like this. We have this tree where these things are defined in edges array, right? And at every node there is a gate. You're also given an integer, an array of even integer. We have an array of even integers, amount which has even integers, and what is the size of it? Price needed to open the gate at node I if amount I is negative, or the cash reward obtained on opening the gate at node I otherwise. So this can have positive or negative values. Positive value means reward, and negative means you have this as charge, right? The game goes on. Every node there is a gate. So the problem seems like this. So this is the node. Each node has some kind of security. Like this. Okay, this is the security. Breaking it will cost you or can reward you depending on the values. There is a game. Initially, Alice has node 0 and Bob is at node Bob. Right, so Bob is at node, so Alice is somewhere here and Bob is at some. Alice is here only. Bob is somewhere here, right? I'll make Bob as a girl so to differentiate it. However, Alice is a girl. Now, for every node, at every second, Alice and Bob move to an adjacent node. Alice moves towards some leaf node while Bob moves towards node 0. So they move to an adjacent node means that this is their position, so they move to some node which is connecting to them. It's a tree, right? They can move freely wherever they want to. Alright. Bob moves towards node 0 and Alice moves towards some leaf node. Some leaf node and it moves towards 0. So basically what I conclude from here is that Alice is trying to move. This is Alice. Alice is trying to move down levels. This is Bob. Bob is trying to move upwards. Every This is a tree, man. This is not a binary tree or something which has only. But you see, they have only n minus 1 edges. What does that mean? Since it's a tree, it is connected, right? And they have n minus 1 edges, there are n people. If you connect them, yeah, so I'm actually feeling unwell today, but let's solve this problem. Right. So what is this problem about? Let's first figure out the uh, requirements. For every node along their path, Alice and Bob either spend money to open the gate or accept the reward. If the gate is already open, no price will be required, nor there will be any cash reward. Okay. If Alice and Bob reach the road simultaneously, they share the price of opening the gate there. In other words, price to open the gate is C, then they both has to pay C by 2 each. Similarly, if the reward is C by C, the reward gets distributed. Alice reaches the leaf node, C stops moving. Similarly, Bob. So Bob is the male guy here. Similarly, if Bob reaches node 0, he stops moving. Note that these events are independent of each other. Okay, it means that Alice can reach at the top and wait, reach at the bottom and wait, or Bob can simply keep running up and up. Return the maximum net income Alice can have if she travels towards the optimal leaf node. So what I sense from here is that Alice is coming down, Bob is going up. So for Alice, it is really easy to find the path which gives it shortest returns. Why is it easy? Because Alice, yeah, it will have that. But the thing is that when can Bob help him? Bob can help him neutralize the negative values. right? If she travels towards the optimal leaf node. Is there any other constraint? I don't think so. Now let's go ahead and highlight the point. This is for simultaneously reach, and this is the already open case. However, what I see here is that Alice will follow some path. This is the path followed by Alice. It is downward, it is some leaf node here. Then Bob will have some path. Since these are independent of each other, what do they want to say? At each, at every second, no, independent है ठीक है, but at every second they need to make moves, right? It is about who reaches there as well. The distance is also a factor. Okay, guys, so I think I'm very sleepy today, but still I'll try to solve this problem, man. Now let's go to the example test cases. So I was thinking what could be the best possible way to solve this problem because I got the problem now. The problem says you are given some nodes here. Actually, we will be given only 4 nodes or maybe 5 nodes. 4 nodes. So one, two, two integer array edges where edges I. Right, so we have been given li AIPIs in which there exists a edge. So there can be maximum n minus 1 from 0 to n minus 1, right? Length of the array is n minus 1 itself. Guys, please wait for me. I'll grab some water. I'm feeling very sleepy. Okay, this is better now. Now I'm up. Now let's go ahead and solve this problem. So let me just focus on the problem statement. So I got the problem statement now. Basically, we have to move, and the movement is like this. We can maintain some state in our code, which will denote like what steps we can choose. Because there are multiple pathways possible, right? If I'm not wrong, there are multiple pathways for each and every step that is there in this particular thing, right? Just give me a second. I'll put my charger on. I'll plug my charger in and there we go. Yeah. Okay, so now, yeah, so let's talk about the possibilities. This guy will move downwards. It has multiple options. It can choose this path, it can choose this path. Ultimately, it will choose some path, and if that path is rewarding, whatever it is, there can be multiple such paths, right? The thing is that only there can be multiple such paths. Then there will be a path which is unlocked by B when it moves above. For B also, B is somewhere, anywhere, right? For B also, there can be multiple paths, but it has to go up. That's a condition. What does that mean? B has to always go upwards. So out of all possibilities of B, okay, so I should see this in this level, basically in level wise. So this is your tree, which can be represented in this form. It has no problems. And here is our starting point, right? So we can take any path. This path goes here, this path goes here. If we take this path, then from here we have two options, and then from here we have one option. From here we have no option, and we can take this path, right? And let's say B is somewhere here. This is the B position. So B can go up, and for B here the only position is this one, and after this the only position is this one, right? This is the positions for B, right? Now B can go only upwards, not downwards. So that is defined based on the root, right? If we take root and if we flatten it, it is sure that it cannot go down, right? So yeah, everything has its own possible paths, and then we have possible paths of B as well. So what B can do? So we can say, like, how many steps? It is a game, right? Return the maximum Alice can have, maintaining the optimum process. So it means be very well placed, right? We have to maximize it. Yeah, we have to maximize that. There will be plus reward, minus reward. Overall, the total sum, what we have to return here is that maximum path, right? Now let's take an example. Example will make it clear. So here we have this 0 to 1, 1 2, 1 3, 3 4. Right, this is minus 2, this is 4, this is 2, this is minus 4, this is 6. These are the gate values which have been given to us. The above diagram represents the given tree. The game goes as follows. Alice is initially at node 0. Bob is at node 3. They open the gates of their respective nodes. Alice's net income is now -2. So first they will open it. So Alice is at -2 and this is at 3. Alice and Bob move to node 1. So this moves here, this moves here. Right. Alice's net income becomes 1. -2 plus 4 by 2 is 2. And Bob's net income becomes 3 to 5. Okay, so Bob moves through the node 0 and stop moving. Yeah. But there can be multiple issues here as well. Okay, so I think this is a simple test case. Now I have to build an approach which will ensure the maximum things. Let's see the time complexity of this. N is 10 to the power 5, it means we need order and solution. There are as many nodes as this. So ultimately they have to reach the root node and there can be two paths for it. First way is this. Right, so what happens here? The first move made by both of them. Yeah, it can go like first the root node has two options. Both options are open. Right? Alice has to spend, bro. Alice has to spend. Then how does Alice know about the future that is coming up? Whether it is Alice or Bob, if they reach together, it means that the height they have spent to come down is the same. But the thing is that height is same, right? But the values. Guys, I'm really sorry. I'm very sleepy. Let me solve this problem, yeah. How to solve this problem? I get blank here because see this how they have done it. Basically, they're saying 0, 1, 2, 3, 4. Bob is here, Alice is here. They are saying that Alice follows this path, and this path. Bob follows this path and this path for free. And here it follows for free and for free. There was reward here of 6. So this is basically a like a solution which can have multiple things span multiple things, multiple possible ways it can have. The maximum number of ways it can have is basically to go down and down and down the depth of the tree. And what is the depth of the tree? Is there any constraint over that? No. So depth of the tree could be anything. The tree is literally random. What can I do in this case? For each and every path. For each and every path, there is something called cost structure. If A traverses it, B traverses it. There is some sort of cost structure. And for each path, there is a possibility that B can never cross it. Right? There is a possibility. Do I have to tap into that possibility? Are you serious? How can I tap into that possibility where I don't know what to do in this case? Basically, the tree is given to us. The tree has these two beautiful things to set up. Then how can I optimize this algorithm to get exactly what we need? How can we do that? We need to optimize this algorithm because we cannot really afford to like check all the paths. And B can literally take any other path. And B can take literally any other path. Can relax it. Basically, B can be used to relax that path, any path that is chosen up. Is this problem breakable? Smaller problems, man. Why it is feeling like DFS, man? Okay, if you see BFS level pay, this will be 0 first node. Then there will be a bunch of nodes here. Right, then there are some bunch of nodes here. The thing is not all these bunches are connected to each other. Okay, so I was saying that this is the possibility, like 4 nodes and 3 sticks. Right, so we have to define which node has the maximum. Okay, so for Alice, I can run a DFS, correct? I can run a DFS for that as well. I can run a DFS where we have to reach to the node 0, which might be at some certain level, and I can find the result output. Okay, now seriously, I have to be serious. Now let me think. How can I do this? Bob is somewhere here. This is Bob. This will be Alice. And there's a possibility of this as well. Alright, so it has numerous possibilities. The endpoint could be here, 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 the endpoint could be here. The answer, which is the final path, is let's say this one. If this is the answer, that means what? the collection at this one would be highest, right? And what is the role of B? B is B part of this? There will be a path, right? So this is basically coming at level this, and B can easily come to this level. Why is there Bob? Bob has to move upwards. So they will simultaneously reach over there, it gets distributed, and at the end they have the distribution reward. What I see here is that uh, yes, one node can have multiple such siblings. How do I optimize this? The thing is, I can calculate the maximum possible path by using some recursion stack, recursion hacks or something. Yeah, one thing is there about the problem space. Now, if Alice has done some traversal down the lane, for that the world changes. The tree which is below that is the space for Alice. Correct? That's the space for Alice. Now, Bob can have entirely different plan. This Bob can have entirely different plan. But Alice can have same plan, and that will not interfere it because that's not the same door. So they keep going up, go up, 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 and up. B guys, there are multiple options to reach there. Correct, there are, and there are multiple options to get down. Out of that, there's one which is the answer. What should ideally be an answer? Let's say this here, this cute little thing here is the answer. Why should be it be the answer? Means that we travel from here till here. We get very good results. We got Alice score to be maximized. This is about finding that path. It has no relation with that. The other guy Bob, if it comes in its path for the negative one, that is okay. B is a leaf node? I don't think so. Bob, basically Bob position is Bob moves to node 0 and keeps moving. Alice moves to node 4. Bob is at node Bob. Do we have Bob given to us? Yes, Bob given to us, right? So Bob has limited options. So Bob problem is actually different. For Bob, we can have chosen anything. Like for each of the path, you get this. Yeah, I think I am getting some sort of दिमाग की बत्ती जल रही है. Like this, something like this. I'm getting here. Like this is the path, and let's say we are doing it for Alice, which is starting from here. If it comes to this place, and let's say Bob is here, so we have to check if Bob comes to this place via any location. Now there could be multiple locations for this. This is just one level up or some levels up. But there can be multiple locations for it. But you notice that this cannot have these edges connected, because if that is there, then they have more than n minus 1 edges, which is bad for the structure. So it is a tree which has no closed loops. All the loops are open. So like this. Now I can quickly guess if C is reachable or not to this node. If C is reachable, yes, it is reachable. Then what we get here? The time taken by Alice. If C reaches here in time t, so here write this yes and time t. Based on that, we calculate the score of this path. Path score is given to us. It's like some famous algorithm. So it can go only up. How do we know it will go up? Which node is up? How do we know that? Basically, we start from 0. We see which node is going downwards. Guys, I'm really very sorry I'm not able to do this live stream today. Please excuse me for the delays which I had. I have to just close it. If there is no subscriber, I will just close it. If there is no subscriber seeing this live stream, I'll close it up. Because I'm not in the state. Yeah. Okay, without any further ado, I'll just check the delays which I had. I have to just close it. If there is no subscriber, I will just close it. If there is no subscriber seeing this live